thank everybody for joining us either this evening, this morning, or this afternoon, depending on what time zone you're joining us from. As Hernan said, my name is Ron Lowry. I'm the Eastern Area Manager for Hazard Control Technologies. I cover the Eastern United States and Canada. In addition, I'm also a firefighter and currently serve as the fire chief for my local volunteer fire department. So what we're here to talk about this evening is, the Class D metal fires and some of the hazards associated with those, especially around some of the current suppression technologies or lack thereof that we have to effectively handle a larger Class D fire. And then we'll look at, potentially how encapsulator technology can actually help us to address that hazard and do it safely and effectively. As soon as my computer wakes back up, here we go. So when we look at those Class D fire hazards, let's look at some of the most common materials that we're talking about, things like magnesium, titanium, zirconium, zinc, the aluminum powders. And the challenge we face is just what I said when we started. We don't have a very good suppression capability. Currently NFPA kind of tries to cover those Class D hazards under the fire extinguisher classification. Well, as the picture to the right shows, in a vehicle fire situation in particular, that's not a good suppression that's not a good suppression function for a fire extinguisher to handle that fire, because you have not only potentially Class D metals burning, but also the other surrounding materials, the other classes of fires that are involved with that vehicle fire that extinguisher can't handle. And 9 times out of 10, exactly what we're seeing in the picture is what happens. We don't know those Class D metals are involved until it's too late. And we've had that mag explosion like you see there and the potential to injure some people. So how prevalent is that hazard, and where can we expect to find those materials? Well, probably the most common is vehicle fires, but it's also sporting equipment. They're trying to make equipment lighter and stronger, so they're switching to titanium and magnesium components within some sporting equipment. Recycling centers and scrap yards, as we recycle those materials once they break. The 3D printing industry, we're doing a lot now with various powders in that 3D printing industry. So you can run into the titanium, the magnesium, the aluminum powders in that industry. Then machine shops, various manufacturing facilities, and foundries. So again, how are we currently handling most of these fire hazards? Well, probably as we see with some of the photos here with fire departments, 90% to 95% of our fires we're trying to handle with water. Unfortunately, with the Class D metals, as we see, they're water reactive, so it's not a good solution. The same thing with your Class A foams, any of your Class B foams. And then we move to the Class D extinguishers, which are our most popular choice, but they're limited to those incipient small stage fires or fires that are just involving that Class D metal. And then, because as we said, you either can't get close enough if it's too large of a fire out of that incipient stage, or it involves materials that can't be suppressed with that Class D extinguisher. And then, after that, it tends to be dry sand and to try and bury that Class D metal. Normally, we revert to that after we've already tried a couple Class D extinguishers and they fail. But again, that's limited to some smaller scale, more incipient type size fires. Once the fire gets a little larger than that, the majority of times it may just mean making the plant burn to the ground. So this Pictures here in the next video is of a fire in Michigan that was at a magnesium foundry where they were making some magnesium parts for the auto industry. I'm hoping we advance here. I may have to get out of the slide and go back in because unfortunately, for some reason, this one slide continues to hang up for me. So we'll go here to a normal view, get to that slide, and then blow it back up. So as you'll see here in a second, what happens when we do it wrong. You know, this is an extreme circumstance, but you know, you get that large mushroom cloud where that magnesium just exploded. You know, that facility there was almost a total loss after that fire. Next one here, this is out in Los Angeles. This is a titanium recycler manufacturer. Well, this slide's going to hang up on me the same way. Here we go.
Everybody all right? Everybody all right?
So the video's starting here. There was already one smaller explosion. So again, this is all piles of titanium that are burning. And as you can see, again, flowing water on that fire.
Okay, guys, I want you backing off. Go off the line, back off. Mike, let's pull out and go defensive. We're okay. All right. Shut down the 2.5-inch line. Shut it down.
So as you can see here, they're still attempting to flow some water on the fire. Those other small fires that you see there in the background, that's the first explosion they had, started lighting some of the other piles that were out in the yard in containers, that those titanium turnings on fire as well.
We'll get 46s on that.
So again, as they're attempting to reorganize now and try and figure a better approach to fight this fire, you have another pretty violent reaction. This fire actually sent 7 firefighters to the hospital.
We got people down. We got people down.
So that's what happens when we do it wrong. Again, with the vehicle fire, the majority of the times with the fire department, again, we don't know that we have magnesium involved until it's too late. So again, those explosions can be pretty violent. Very dangerous if that magnesium gets into your skin. Turnouts, it can actually burn straight through. So, you know, are you prepared to handle this hazard currently today in your department or in your industry with the capabilities you have? So now let's look at some potential solutions for these hazards. And I think probably the best solution out there from an all-around firefighting point of view is the encapsulator technology. Excuse me, one too many. So what is an encapsulator agent? Again, it's a type of water additive whose basic building block is that spherical micelle. That micelle is capable of encapsulating both carbons and hydrocarbons in both the liquid and vapor state, sealing them off from the oxygen. And when we look at F500, that is a 100% fluorine-free, non-corrosive, biodegradable encapsulating agent. It is UL listed for Class A and Class B fire suppression. It's been tested and proven effective on Class D fires, and it can also be used as a flammable liquid spill control agent.
Encapsulator technology.
Video here that'll explain how the agent interacts with water and what makes it effective.
The next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet.
Sorry, I was trying to grab that right before it did that. So when we look at this orientation right here of the water droplet,
in each droplet,
especially in the Class D application, this is what makes the agent so effective. So when that water droplet is formed and you get this skin of F500 on the outside of the water droplet, that's why we don't see the reaction when you use an encapsulator agent, when you use F500 in that Class D application, because you no longer have that H2O molecule that's actually contacting the Class D metal. You have a F500 molecule that's actually the first thing to touch that Class D metal. Those F500 molecules on the surface actually work like a heat sink. They absorb that heat and transfer it to these micelles within the water droplet, which gives you rapid cooling, which is the way we can effectively suppress those Class D fires. So we eliminate the interaction, that reaction, because of the skin of F500 and because of the micelles, we can rapidly cool that Class D metal to extinguish the fire. So when we talk about the encapsulator agent and its unique capabilities, the first one we want to talk about is that encapsulation. So we're able to encapsulate those flammable gases that may be given off, or flammable liquids, sealing them off from the oxygen, separating the fuel from the oxygen on that molecular level, rendering them non-flammable. Video here, I think, is a good depiction.
Hazard control technology.
As you will see, we're actually going to go ahead and pour some E10 gasoline on the ground. We'll go ahead and encapsulate part of that spill and then go ahead and ignite the other portion. As you'll see, the only thing that's going to burn is that non-encapsulated portion of the spill. There's not a foam blanket on there. There's no bubbles to break down. That fuel is sealed off inside that chemical cocoon, rendering it non-flammable.
Flame is applied, but only ignites the
firefighter can come back in now with that same hand line, finish extinguishing the fire.
The F500 encapsulates the gasoline vapor molecules, rendering them instant.
And then they'll come back along with that torch, showing that that fuel's been encapsulated and it's no longer flammable.
The F500 solution on the ground without any reignition. If this were foam, the gasoline would have reignited where he kicked the foam aside.
So if you would have a foam blanket and he was walking through it just now like that, you would potentially be breaking your blanket down, exposing fuel vapors and getting ignition. But because we work in that molecular level and don't depend on the bubbles to separate the fuel from the oxygen,
hazard
you
control
no longer have that hazard. That next unique feature, as I was talking about earlier, is that rapid cooling, that F500 skin on the surface of the water droplet working like a heat sink, absorbing that heat and transferring that heat energy into the internal portion of the water droplet. And when we talk about rapid cooling, that's what you're going to see here. Titanium turnings. So we're using an F500 extinguisher with 10 ounces of F500 in there mixed with the water. It gives you a 3% solution. So rapidly cool that Class D metal to the point that you can pick it up barehanded right after it's extinguished. That's the cooling capabilities of the agent. Go from a burning multi-thousand degree titanium to literally being able to handle with bare hand within a couple seconds. And the last feature is, again, the ability of the agent to actually interrupt that free radical chain reaction, stop soot and smoke from forming. Not really all that important with Class D, but it's definitely going to help you with some of the other surrounding materials that potentially could be burning, particularly in a vehicle fire situation with the plastics and the rubbers that are involved. We have 5 burning tires. We're going to be using a 1% solution of F500 through the TKO nozzle. Just keep an eye on the smoke that's being given off by those tires, and you'll see what we mean by stopping that soot and toxins from even forming. Though the tires are still burning, as you see, that black, heavy, toxic, soot-laden smoke is gone. That's the ability of the F500 to stop those soot and toxins from even forming into smoke. So drastic improvement in visibility, drastic improvement in the amount of soot and byproducts that are being given off that the firefighters and the general public are being exposed to, and also reducing the toxins within that smoke. Just another added safety benefit that you get with encapsulator technology. So when we talk about the applications with F500 on a Class D fire, what we want to look at is you need to ensure that you're flowing a 3% solution of F500 prior to attacking that fire. Generally, we tell folks, make sure you're flowing your nozzle off to the side until you see that white milky substance coming out of the nozzle. Again, you're not going to see a bubble. The agent's actually going to look like a 2% milk coming out of the nozzle. When you see that, you know you have a good solution of F500 in your hose stream. You want to use a dispersed pattern and start to rain down the agent onto the burning metal. So particularly in that magnesium, you want to take that metal from burning in that white hot state. Once you get it down to more of an orange glow, you can start to tighten your stream up a little bit and do more of a direct attack on the metal. If you start to get a reaction, so once you tighten up your pattern, if you start to see some reaction, you get a little bit of sparking. It can happen if you hit with too tight of a stream. Just back your stream back off and continue to use that, little less of a straight pattern, more of a dispersed pattern until you've completely suppressed. This video here, again, this is titanium and zirconium turnings. We're again going to be using the F500 extinguisher. As you can see, same way that that wand type, mist type application, we're using that dispersed pattern to pull and suppress the fire, remove that heat, rapidly controlling and pulling that fire to complete extinguishment.
Just kind of hit it some with the
Ron, can you download the sound, please? Yeah, the sound is loud.
So this next one is actually magnesium again. This is a magnesium lawnmower deck. So this Lawn Boy lawnmower, magnesium mower deck. Again, hand line application here. That's a larger block of magnesium. You can see that rain down application that he's using a dispersed pattern, raining down. You'll see once cameraman's going to get around to the side, you'll see, as we talked about, that white glow going more to an orange. Now he's doing more of a direct attack now that he's cooled that magnesium down from that white hot. You know, he may have taken it from 5,000, 4,000 degrees down to 1,200 degrees. So he can now do more of a direct attack on it. Doesn't need to worry about the reaction that you would get. So again, 42-second suppression. Firefighter's going to go ahead and take his glove off. Again, that rapid cooling. He can go ahead and move that mower deck with his bare hand. He'll bring it back to everybody else that was at the demo, allowing them to touch it and see it. So that's again, the cooling capabilities that we're talking about with the agent. It's not like using a standard Class D extinguisher where you're trying to form that crust and just smother the fire, and then you have to leave it sit and, you know, nobody disturb it for 6-8 hours until it naturally cools enough that it puts itself out. You're just smothering it. Next video here, this is vehicle fire again. This one's going to have a magnesium steering column and a magnesium seat frame on the driver's side. Again, we're using a 20-gallon per minute nozzle on this vehicle fire. Again, rapid knockdown. It takes me a little longer than I would have wanted to get it around to the entire car, but unfortunately with this training, I was working the line by myself and pulling about 300 feet of hose. So it was a little difficult to move quickly around the vehicle, or at least as quickly as I would have wanted to. Again, that's one of the techniques I talk about when we're fighting vehicle fires. You don't need to continually flow the product. You know, attack the fire that you see, knock the fire down, and then shut the line down and see what you have. So you see there, had a little bit of that initial tight pattern when we hit the magnesium and had just that small flare. Now again, using that dispersed pattern, starting to cool both the mag on the floor and the mag up there on the steering column. Going to reposition the line here in a second so we can get more of a direct attack right at the magnesium that's burning. Just like any fire, you have to actually get agent on the fire to put the fire out, be that F500, water, or whatever. So there were just a few videos to actually show you some of the application techniques as well as the effectiveness of the agent for those types of applications and those types of fires. Open it up now. If anybody has any questions, let's shoot away.
Thank you, Ron. We have from Brian. Brian, can you open your microphone and make the question? Yes, I don't know if you see the question.
Yeah, hey,
Brian.
Yeah, Brian. So using the TFT nozzles on your attack line, is there a special type of nozzle you need to use with F500 in a water can? So hazard control, we do sell a specific nozzle for our water cans. It's a water mist hose application. And the reason we're doing that is because, in our opinion, it makes the extinguisher the most effective on the most classes of fires. So if you would be using a traditional smooth bore nozzle like you have on a fire extinguisher on a normal fire department water can, and you would use it in that Class D application, you would need to go ahead and, throw your thumb over the end to break the pattern up, which isn't a really good solution for some of our industrial clients. And sometimes with the fine mist, it's not as good on a Class A fire. So though you can use that smoothbore nozzle, our recommendation would be to go ahead and, retrofit some of your extinguishers with that water mist hose that we have, just because it makes it the most effective it can be on the most classes of fires, including lithium ion batteries. To your question of TFT nozzles, the only thing I would caution is if you are using an adductor and you're using an automatic TFT nozzle, you can have some issues not knowing what your flow rate is out of the nozzle, depending on the type of adductor you're using. If you're using an adductor, you need to make sure that your nozzle GPM matches your eductor flow. So if you're using a 90 gallon per minute eductor, you need a 90 gallon per minute nozzle. If you're using a 125 gallon per minute eductor, you need to use a 125 gallon per minute nozzle. As far as if you're batch mixing or you're using an onboard proportioner or around the pump proportioner, you can use any of those TFT combination nozzles. I actually have those I use smoothbore and combination nozzles with my department, and we're currently running the TFT automatics on my apparatus. I hope that answers your question.
I believe you answered the question, but Tyler said, what about the results on a lithium battery? I don't know if you want to share the video.
I don't of a lithium ion battery fire.
Yes. I don't know, Tyler, if you want to open your microphone. It's about lithium batteries.
Yes, that's correct.
Yeah, let me go find one of our lithium ion videos here.
So I'm thinking more of an electric vehicle.
So I can tell you, so an e-vehicle fire, a fire extinguisher is not going to give you enough volume to extinguish an electric vehicle fire. So if you have power tools, laptops, smaller exposed batteries, that's going to work. If you're talking a Tesla or a Chevy Volt, you're going to need a hand line to put that out with F500 in it. So, currently it's copious amounts of water. Some of the testing that was done with F500, F500 was able to extinguish a burning lithium ion battery with about 5 liters, where 50 liters of water couldn't extinguish the same burning battery when they did water to F500 testing. So that's better than a 10-to-1 advantage. So if you extrapolate that, as opposed to 20,000 gallons of plain water, you may be able to extinguish that e-vehicle with 2,000 gallons of an F500 solution, just as drawing a comparison, small scale to large scale. If you want, I can pull up here a battery fire here in a second. Let me go ahead and change my screen.
Can you see the video, Ron?
Yeah, you have it up now, Hernan. Thank you. Yeah, so this is the F500 extinguisher over here with that water mist one. Again, sorry, thanks, Hernan. I was actually looking for it on my computer.
Yeah. You have foam, dry powder, and
you have the dry powder, the foam, and then the lithium ion. And again, don't get the lithium ion batteries confused with a lithium battery. A lithium battery is a Class D metal fire. A lithium ion battery is not a Class D metal fire. There are lithium ion. Theo, help me out here with the official name, because you're better at it than I am.
Yeah, when you're talking lithium ion batteries versus lithium batteries, you're talking one's just basically a flammable electrolyte with with lithium ions as a component of it, as opposed to a full-on lithium metal battery where you actually have the combustible metal component, which is which is the water reactive side of it.
Yeah.
So when we're dealing with, let's say, like Tesla's or any of the other kinds of manufacturers with lithium ion batteries, we're dealing with basically flammable electrolytes that contain lithium ions.
Yeah, I always get confused with the lithium hexafluorophosphate. Was I right?
Yeah, lithium hexafluorophosphate is one of the components of the lithium ion battery. And then you have the actual flammable liquid components that go along with that.
Yeah. And especially, when we get back to, it brought up the electric vehicle fires, and some of the recommendations to use copious amounts of water, just like we saw with the combustion engine fires with the magnesium. You still have those, probably more so, those magnesium components in electric vehicle fire. So, I would say if you look at a Tesla Model X, which has magnesium DeLorean doors on it and a magnesium spine that runs down the roof of the vehicle to support those doors, I personally wouldn't want to try throwing copious amounts of water onto that burning Tesla Model X. So when it comes to especially the e-vehicle fires, the F500 gives you the solution of not only being able to extinguish the lithium ion batteries like you're seeing now, but it can handle that Class D metal that's going to be involved without the violent explosions. It's going to be able to handle the plastics, the rubbers, and that whole time as you're using it, it's going to help, as we saw with the burning tires, reduce some of the toxins that are being given off by those burning components. So it not only, to my opinion, gives you a better suppression capability, it gives you a safer and more effective suppression capability. Yeah, Bob just asked a question about the increasing in the lithium ion batteries and them being everywhere. Was just an article I just saw the other day. It's part of, at least here in the US, as part of that infrastructure bill, was about 145 billion to be used to upgrade the EV charging capabilities throughout the country. In addition, both General Motors and Ford are saying they want to be completely electric by 2030 or 2035. So literally within the next, 10 to 12 years, at least here in the US, two of the major auto manufacturers are planning on being completely electric. So that is the hazard that we're going to be facing moving forward, at least in the vehicle fire realm, or the, fires involving automobiles.
Ron, can I share a video about a car fire with temperature, with thermal camera?
Sure.
Here you have 1,200 centigrade. See the number here?
Yeah, the pre-burn on the car.
Yes,
And again,
I move forward in this
Yeah.
moment. In this moment, in a few seconds, one person with a TKO arrived and see how fast download the temperature here. Here you have 500 now. See the number, 4 minutes, 11 seconds. Yes, and he start with A500. See, we don't have more temperature of 1000 centigrade. See the time. We start 4 minutes, 11 seconds, and now it's 4 minutes, 32 seconds.
Why is it doing that?
He's sprayed to the other side. But less than 1 minute, you have the control of this car fire, and you download the temperature of all the metal. Okay. This I move forward the video, but only to show he opened the door, and see when he opened the door of this size, see the temperature inside the car. Okay. He's looking for the hot spots to finish cooling all the car. Yeah. Thank you, Ron.
Turn on.
Hernan, I'd like to just add something to that last video. I know you said it's a TKO nozzle. I want everybody to understand that's a 20 gallon per minute nozzle, not a 95 to 125. So that knockdown was in 21 seconds with 20 gallons a minute. So that's pretty impressive compared to using 95 to 125, what we're used to in the fire service.
Yes, thank you, Steve, for your input. Somebody asked Ron if we have a distillation column, if we can cool the distillation column in three-dimensional fires.
Yes, we have that video as well. I just need to find it. Okay. 2 seconds here.
Let me know if you want. I can looking for the video too.
Yeah, I got it here in a second.
Okay.
Technologies presents F500 encapsulator technology.
So this is a distillation column flowing gas.
This demonstration in Chongqing, China shows the effectiveness of 3% F500.
So both encapsulating the fuel and cooling that steel structure to take the heat away to eliminate that auto reignition.
And cooling the fuel and metal well below the auto ignition temperatures.
Kind of anticlimactic from some of the distillation column fires that we've seen.
Okay. How is the difference between foam and the encapsulator technology in three-dimensional fires?
So with foams, we're trying to form that blanket to separate the fuel from the oxygen, and that's impossible to do in that three-dimensional fire. Whereas with the F500, because we can work on that molecular level, it actually works in that three-dimensional application, so that we can encapsulate those fuels on that chemical molecular level, as opposed to trying to form a blanket over a three-dimensional object. The agent can actually encapsulate the fuels and cool that surrounding metal structure to give you the ability to suppress that fire much more rapidly than you can. Most of those three-dimensional fires would be a dual agent type of application where you would be attempting to put a foam blanket down on any fuel that was on the ground while using Purple K to try and handle the three-dimensional aspect of the fire. So again, two different agents, special nozzles that will apply both agents in combination. So most things that I would say 90% of the fire service out there, probably 95% of the fire service either doesn't have or doesn't have access to. F500 is the agent that you can use with the equipment you're already carrying on your truck to handle darn near any fire you're going to go to.
Will our F500 dealer have the water can nozzles to sale? Yes.
Yes, absolutely, Chief. And we can get you those last couple webinars that we've done as well. We can get you the PowerPoint and the recordings of those.
Somebody want to make, we have a question, but it's in Spanish. That's our friend from Panama, Fulvio, asked if we can use this product only with firefighter, or we can use in fire brigades in industrial. You can use the product in your house. You can use your product in the industry. You can use the product in the fire brigade, or you can use the product in the fire department. It's not only focused to the fire department. Ron, I explained very well in English?
Yes.
Okay, thank you. Thank you for your support. Okay. Graham, do you want to make some questions from Australia? You have some people of your territory. New Zealand, we have some friends of this part of the world.
Yeah, thank you, Hernan. I think we see an application in mining here massively. I mean, they lose vehicles at a monotonous rate, and something like this with the TKO on a normal water truck, which they have running around anyway, it's got to be a no-brainer for these people.
Yeah, and just with you saying mining, Graham, the agent is actually, it has here in the U.S. MSHA, which is Mine Health and Safety Administration approval for mining. So it is also an MSHA approved agent.
What was that acronym again, Ron, please?
MSHA, it's Mine Health and Safety Administration. It's another government bureaucracy here in the U.S.
Alrighty, thank you, Hernan. You know I'm going to be asking you for a copy of that certificate, please.
You know that we are using Graham here in Argentina. We test our product in a metal company that they create parts of car, and they start to use this special download the temperature with the product to cool the machines where they make pieces for
forge.
Yes, for car factories. Yes, because they have to wait, they stop the machine and they have to wait some time, and they have a special product that download 30 centigrades. And when we test in the machine with our product, we can download 130 centigrade. We can download 100 centigrades more and say, oh, wonderful, because they can stop the machine, they can cool with the product, and they can continue working in this mechanic company. This is more we understand how work this technology we can use for industry, and not only on thinking on fire, thinking how you can use this technology to cool, to protect, for other process that you can use for trains to cool the machine or to cool the engine. That you don't have to stop the train, and you continue working with this.
And then I have a,
You have an application of metal.
I have an application for Graham. I work with large copper mining companies here in the U.S. And one of the best uses that they found is to prevent belt fires, the large belt fires on their conveyor systems. Because what will happen is they'll have a hot bearing on a belt system. And what they've normally done is just simply stop the whole thing. Well, it catches the belt on fire, and those belts are like 1 inch thick or more. And they burn up $100,000 belt just by using 2.5 gallon water cans with F500 in it. They'll now go up and hit the bearing first, then stop it, and they've eliminated their belt fires, which is huge for them. That, and they use it obviously in the with haul trucks. You probably have large haul trucks there in Australia, the same. So we have, I think we have the largest one, we have like 400 ton, but big tires, obviously. So it works well on the hydraulic fluid fed fires. When the dry chem can't put it out, ours will put it out. So
Brilliant. Thanks, Mike. Appreciate that. We've still got some big trains and and loading facilities down at the docks. You know, the ships stand off or just off the wharf a bit, and they have conveyor belts running all sorts of, from wheat to coal to all sorts of things straight over to the ship. And it's a massive deal if they have to stop. It's massive.
absolutely. And we also do have the same use in the coal transfer when you're talking about transferring like Powder River Basin coals.
Yeah.
And the real high combustion coals, works well there.
Thank you.
So the question was just posted on the fiberglass foundry fires. I'll go ahead and share this video with you
Presents F500
and show you an application on, this is a fiber.
This fiberglass boat fire was extinguished in seconds using a 0.5% F500 encapsulator agent mixture. Watch as the thick black toxic smoke turns white as a result of F500EA interrupting the free radical chain reaction.
Temperature? 100.
The temperature is reduced from 1000 degrees Fahrenheit to 100 degrees Fahrenheit very quickly, showing the rapid cooling capabilities of F500 encapsulator agent.
Wow. Unreal, isn't it? Absolutely.
The most important thing is how you can download the temperature with the fiberglass, but how you can encapsulate the black smoke and move to this white. This is how you can reduce the toxin of the smoke in this case. Okay. Thank you. And we have the last 5 minutes. If somebody wants to make some question or make some comment.
I have another question for you, Graham. On the recent Megapack fire from Tesla. They had nothing to put on that but water, correct?
Yeah, that's right. Well, we've been onto them and we're still on them.
And they didn't have any fire systems. To my understanding, there were no fire systems in those Megapacks.
I'm not sure about that. They had stuff that was being sprayed externally. I'm not sure what they had internally. What really puzzles me is this is a dinky die Tesla battery unit, the Megapacks, smaller, but not dissimilar to the ones that you guys have. Why the heck wasn't F500 specified in the first place? We don't know that, but we're trying to find out what the story really is.
Because the right hand doesn't talk to the left.
Oh yeah, that's for sure.
I-
Bear
I
in
have-
mind, we're upside down here, so it's really confusing. But
I have
but-
the same question for them too, because I work with Tesla's Gigafactory, putting fire systems in for them. So I've probably put in 12 or 13 fire systems for them to protect their battery charging units where they power up their batteries to test them. And it's true, when you have an outfit that big, sometimes one group doesn't know what the other group's doing. But my understanding, this was a French company that was putting these battery systems in. So, and I'm not going to fault the French, but they may not be aware of the suppression technology. But all they have to do is, that doesn't still make sense, because Johnson Controls in Europe is using F500 for lithium ion there.
Well, they're aware of it now, mate, because we actually quoted all of those things and let them know and acquainted. I mean, we've certainly got their interest. There's no question about that. And when we'll follow it through to its logical conclusion, which I'm hoping will be that they'll adopt the tried and tested methods that are already out there. Why the heck do we have to reinvent that wheel? I don't think it's just beyond comprehension that they should miss something that important, really.
I have a question for Theo and Ron, but it's in Spanish. I try to translate. The question is the fire protection that's use the trucks on mining. They use wettination and dry powder. We can use A500 in this case.
Yes.
Why?
Well,
This is my question. Why?
The problem with it, dry chem is an excellent extinguishing agent, but it has its limitations. If you can get that fire out initially, you've won the battle. But if you've exhausted that material, it does nothing to take the heat away. And that's the problem with heavy equipment fires, is that hydraulic fluid is so hot that you may extinguish it initially, but because of the residual heat there, it still auto ignites, and now you've lost a very expensive piece of equipment. Whereas the F500 is doing two things. It's cooling the material below its auto ignition temperature, but it's also inerting the material so that it can't burn. And that's what the real benefit is there, is that it's basically taking an oil-based material and turning it into a water-soluble solution, and water doesn't burn.
Oh, wonderful. Like how we are talking about trucks in mining, and maybe you have experience. I received a question from Brazil and Peru. If we can use the same product to clean these huge trucks when they finish to work with grease, oils, can we use the A500 to clean these trucks on mining?
Absolutely.
Do you have any experience of this?
I have experience with this because we work with Caterpillar in Southern California, and when they bring their rental equipment back in, they're using F500 solution to clean off their heavy equipment. And there's a lot of soil that gets eventually piled up there. What they find is after they've stockpiled the soil, the material helps bioremediate that soil, and they've literally gone from hauling it off to a hazardous waste facility to being able to use it as fill. The liquid that they used to haul off, they were paying, I think it was paying like a dollar, a couple of dollars a gallon to get rid of it. Now they don't have to get rid of the liquid anymore. They can use it to use it for dust control on roads. So it saved them considerable amount of money, plus it's doing the benefit of degreasing and cleaning their heavy equipment.
But when you clean this heavy equipment, Theo, and you encapsulate this, you don't have to clean, or you don't have to take off the ground. The ground remediate in the place.
Well, what they do is they take all the soil that's come off of them, and they, if you know what K-rails are, basically they're little concrete structures, kind of like you see on the freeway where they make dividers out of them. They put the dirt in those K-rails, and then they'll take the material that they've used to clean off the vehicles with, and they'll take that material and they'll spray it on the soil, and it will help remediate the soil. And after about a month, they test it to make sure that the hydrocarbon counts sufficiently okay, and then they can use the soil for other things.
Oh, okay. Okay, you have the same product for two different, for cleaning and remediation.
Correct.
And if we have some problem in the truck, we can cool the truck.
Right.
It's cheaper, the product. Thank you, Tito. Okay, guys, we are on time. Let us know if you have any question, any comment, if you want to share with us some example that you have in your territory, or you use the A500 in some metal company, in other fire, please, it's your time. If we don't have more questions, please send me, we have the mail. I will put the mail here in the chat for everybody.
Hey, Hernan?
Yes, please.
One last question. Looks like Zach Parsons, probably from Canada. He's got a question on, it says, I work at a nickel refinery in Canada. Our challenges with our nickel concentrate is that it's water reactive when on fire.
Thank you. I didn't see the question.
My answer is I don't know unless Ron knows that we've actually done any testing with that particular material. I guess the shorter answer is that I don't know that we've tested it, but it's one of those things. If we don't know, we just go out and we try it.
Yeah, and I agree with Theo. To my knowledge, we've not done nickel. I can tell you I've personally done zinc, zirconium, magnesium, titanium. I know Theo's done thermite. So there's, when it comes to purely metals, and I've done lithium as well. There hasn't been any that I have seen that it hasn't put out, but absolutely, if you got some nickel, Andre Barroso would be your,
I will be more than glad to help this.
Help you. We can do some testing. Let's go burn some and find out what happened.
And only to let you know that we test in mining in Chile with heavy metals. I don't know if it's the correct name, but in the ground, when we have a spill, we can encapsulate difference and download this quantity. And I will check, because I remember that maybe we have nickel. Yes, but I would send this information, but I have to check. I know we have a lot of these heavy metals that we can download in the ground. But please contact with Andre Burasa, that is our specialist in Canada, and he has to work because he retired of fire department, and we have to push toward this new guy.
We need to keep
how
him
many
busy.
years, Andre? Like fire chief?
Pardon me?
How many years do you?
45.
You are
I did
so
45
young.
and a half years.
Okay.
But I'm still active as a deputy chief in a smaller fire department.
Thank you, Andre. You will have to talk in French in the future webinar. Okay, let me see. I don't know, Theo, if you see the chat, if we have other questions.
Yeah, I don't see any more, Hernan.
Yes, change my detention. Okay, guys, thank you for your time. Thank you for your patience. And we will try to be in contact for the next webinars to share with all of you with more information in different classes of fire, in different solutions.